everyone. In previous lecture we have discussed about Wheatstone bridge. In today's lecture we are going to discuss about Metre Bridge. First of all, we are going to discuss introduction to Metre Bridge. Metre Bridge is popularly known as slide wire bridge. The Wheatstone Metre Bridge was invented in the year 1833 by a famous scientist Samuel Hunter Christie, which was later enhanced and popularized by a scientist Charles Wheatstone in the year 1843. Slide wire bridge is used to determine the unknown electrical resistance value of a metal coil. In this device, a wire of unknown resistance is used and it is connected to a galvanometer by using a slider. So it is called as Wheatstone Metre Bridge. A length of wire is 1 meter used, so it is called as Metre Bridge. In Metre Bridge, a wire of nichrome, manganese and tungsten are used because it has high resistance and low temperature coefficient of resistivity. Next we are going to discuss principle of Metre Bridge. Metre Bridge works on the principle of Wheatstone Metre Bridge circuit, which says that at any point or a length of a wire, the ratio of two resistance is equal when the ratio of another two resistance, and no current will flow at that point when edges containing resistance. Therefore, apply it to the Metre Bridge. It says that galvanometer will show a zero deflection, and it helps to find the unknown resistance of two conductors or to compare two unknown resistance. It is based on the principle of null deflection. The ratio of two arms of a resistance is equal when no current will flow through the mid-arm of a circuit. Next we are going to discuss components of Metre Bridge. This device is required to find the unknown resistance of a conductor, and some of the components are listed below: Metre Bridge, resistance box, connecting wire, galvanometer, screw gauge, unknown resistance of length 1 meter, one-way key, Lagrange cell, jockey. Next we are going to discuss components of Metre Bridge in detail. First one, wire. Metre Bridge consists of 1 meter long manganese or a straight wire with uniform cross-section area, which is fixed on a wooden block. Next one, jockey stick. Jockey is used to slide on a bridge wire. It is a metallic rod with one end as a knife edge. Next one, metallic strip. Two L-shaped metallic strip and one straight metallic strip used to form a Metre Bridge. Next one, connecting wire. Connecting wire is used to complete a circuit connection, and it allows a flow of current through it. Next we are going to discuss resistance box. Resistance box is a variable resistance which is fixed at the one end of a circuit. If any circuit required variable resistance, then no need of replacing resistor in a circuit. Galvanometer. Galvanometer is a device used to detect the presence of small values of current and voltage for measuring their magnitude. Galvanometer is mainly used in Metre Bridge and Potentiometer, which indicate null deflection and zero current. Unknown resistance wire. This wire is used to find the resistance value in the Metre Bridge. Next we are going to discuss construction of Metre Bridge. Metre Bridge consists of 1 meter long and uniform cross-section area, which is stretched tightened. Now the wire is stretched along the meter scale. The bridge has a two metallic strip which is riveted on either side of a wire. The metallic strips are clamped on the wire. The wires act as a holder for a metallic strip. Within the gap between the two metallic strips, the resistors are connected. In the first gap, the resistance R is connected. In the second gap, a small resistance wire S is connected. At the end point, the wire is being clamped or connected to the cell through the keys. At the galvanometer is connected to the metallic right, and it is in the middle of a two gap. Jockey is connected to another end of a galvanometer. Jockey is made up of metallic strip and one end as a knife edge. Jockey slides over a potentiometer to make an electric connection. Jockey is used to slide over a Metre Bridge wire until the galvanometer shows a zero deflection. Next we are going to discuss about Metre Bridge working. To begin with, move a jockey to the end point on the wire A and C. The deflection of the galvanometer should be opposite on both the sides. From side A, start sliding a jockey over a wire until the readings are observed, and deflection of the galvanometer should comes out from 0. If such point is not obtained, try to vary the resistance across the bridge by varying the resistance in variable resistor. Once again, start sliding a jockey on a wire until the deflection of the galvanometer comes out to be 0. This point is said to be a null point and it is represented by a symbol B. Obtain a length of null point using a meter scale attached along with the wire. This point is called as balancing length of meter bridge. Let distance between the point A and B be L1. Let distance between the point B and C be L2, where L2 is equal to 100 minus L1. When the galvanometer shows a null deflection, the meter bridge behaves as a Wheatstone bridge, as shown in diagram below. Next, we are going to discuss how to calculate the value of unknown resistance. If S is an unknown resistance in above circuit, we can calculate its value by using meter bridge method. In balancing condition, R divided by resistance across a length AB is equal to S divided by resistance across a length BC. We know that R is equal to rho L by A, where R is equal to resistance, rho is equal to resistivity, L is equal to length of a wire, A is equal to area of cross section. By using this relationship, if we know the resistivity rho and area of cross section A for a given meter bridge, then we can find the resistance across a length AB is equal to rho L1 by A. The resistance across a length BC is equal to rho L2 by A. Substituting this above relationship on a balancing condition, we get R divided by rho L1 by A is equal to S divided by rho L2 by A. In the above equation, we cancel rho and A, we get R divided by L1 is equal to S divided by L2. Therefore, we know L2 is equal to 100 minus L1. Substitute this L2 in above equation, we get R divided by L1 is equal to S divided by 100 minus L1. So, cross multiply, we get S is equal to 100 minus L1 into R divided by L1. If you want to find the value of unknown resistance S, by using this formula we can find, that is rho is equal to pi d square S divided by 4L, where d is equal to diameter of wire, L is equal to length of a wire, S is equal to unknown resistance of a given wire. Next, we are going to discuss what are the possibilities of error that may occur in meter bridge. The most common error that may occur the measurement accuracy of a meter bridge wire is N error. The N error may come up with the following reasons. We know that along the length of the wire, the scale is provided. If 0 point of a scale will not coincide with the bridge wire, then 100 cm of scaling point will not coincide with the end of the bridge wire. It may lead to incorrect measurement of balancing point length. The non-uniformity of metal wire might lead to generation of stay resistance. This will lead to create end error in meter bridge circuit. We can minimize this end error by taking multiple reading for an experiment, by calculating a final value of resistance, by taking average mean value for all the observation reading. Next, we are going to discuss limitation of meter bridge. Copper strip have their own resistance, but in calculating a meter bridge formula, we neglect resistance, so that results are errorful. For minimizing this error, at the time of performing an experiment, we have to calculate the unknown resistance value by interchanging the known resistance with unknown resistance. In this process, we have to take a mean observation of all reading so that errors can be minimized. The resistance of an end point should not affect the sensitivity of meter bridge. To nullify this effect, Carey-Foster bridge is used. Current should not flow longer duration of time in the wire. Otherwise, the wire may heat up and the value of resistance will changes often. The jockey should not slide tightly on the wire. Otherwise, the area of cross section of the wire will changes. This is why resistance changes in the meter bridge often. Next, we are going to discuss advantages of meter bridge. to find unknown resistance value very accurately, as this method does not involve in the measurement of voltage or current directly with ammeter or voltmeter. Next, we are going to discuss disadvantages of meter bridge. It is not suitable for high resistance value to low resistance value because meter bridge is very sensitive at length L1 is equal to 50 cm. Meter bridge wire may not be exactly 1 meter long, which may give rise to error in the measurement. We have come to the end of a section. I hope you all understood today's topic, meter bridge, construction of meter bridge, working principle of meter bridge, limitation of meter bridge, advantage and disadvantages of meter bridge. In the upcoming lecture, we are going to discuss about potentiometer. Thank you.